So today we will be discussing the concept of molecular mass and mole concept from the chapter Atoms and Molecules, class 9. Molecular mass. The number of times a molecule of a compound is heavier than 1/12 of the mass of a carbon 12 atom is known as its molecular mass. In simple terms, you can say the molecular mass is equal to the sum of the atomic masses of all atoms present in one molecule of a substance. For example, let's take the molecular mass of H2O, which will be 2 into mass of one hydrogen atom plus mass of one oxygen atom, that is 2 into 1 plus 16, which becomes to 18 atomic units. Now comes formula unit mass. The formula unit mass is calculated in the same manner as we calculate the molecular mass. The only difference is that we use the word formula unit for those substances whose constituent particles are ions. For example, here let's take the formula unit mass of ionic NaCl, that is 23 plus 35.5, which will give 58.5 atomic units. Mole concept. A collection of 6.023 into 10 raised to power 23 particles is named as 1 mole. A mole is the unit of measurement for amount of substance in International System of Units. A mole of substance or a mole of particles is defined as exactly 6.023 into 10 raised to power 23 particles, which may be atoms, molecules, ions, or electrons. 1 mole atom is equal to gram atomic mass and 1 mole molecule is equal to gram molecular mass. Avogadros constant or Avogadros number. The number of particles present in 1 mole, that is 6.023 into 10 raised to power 23 particles, is called Avogadros number or Avogadros constant. Here is a flow chart describing the relationship between mole and Avogadro number and the mass. So here we can say 1 mole of carbon atom, which is equal to 6.023 in 10 raised to power 23 atoms of carbon or 12 grams of carbon atoms. 1 mole of hydrogen atom, that is 6.002 into 10 raised to power 23 atoms of hydrogen or 1 gram of oxygen atom. Same goes here. 1 mole of any particles that is equivalent to the Avogadro number of that particle and relative mass of those particles in grams. 1 mole of molecules, 6.022 into 10 raised to power 23 numbers of molecules, that is equal to a molecular mass in grams. Atoms and IUPAC convention. What is an atom? The smallest tiny particle of any matter which further cannot be divided and is indestructible is called atom. Atoms are also the smallest building blocks of matter. For example, sodium, hydrogen, oxygen, etc. IUPAC, that is the International Union of Pure and Applied Chemistry, approves the names of elements. The abbreviation used for lengthy names of elements are termed as their symbols. The symbol of an element is formed by writing only the first letter or the first letter followed by the second letter or some letter in English or Latin of the element. While writing a symbol, the first letter should always be capital and the second letter, as always, small. So here is the chart giving out the names of the elements. So let's take a few examples. For example, aluminium is termed as Al, copper Cu, and nitrogen N. Argon Ar, fluorine F, and oxygen O. Atomic mass and gram atomic mass. Atomic mass of an element may be defined as the average relative mass of an atom of the element as compared with the mass of an atom of carbon, C12 isotope, taken as 12 atomic mass units. The atomic mass of an element expressed in grams is known as gram atomic mass. Molecules. A group of 2 or more than 2 atoms of same or different elements that are chemically bonded together is called a molecule. For example, 2 atoms of hydrogen and 1 atom of oxygen, when they react chemically, they form 1 molecule of water. Atomicity and molecules of elements. The number of atoms present in a molecule of of an element or a compound is known as its atomicity. For example, atomicity of oxygen O2 is 2 while that of ozone O3 is 3. The molecules of an element are constituted by the same type of atoms. For example, a molecule of oxygen consists of two atoms of oxygen to form a diatomic molecule O2. Atoms of different elements join together in definite proportion to form molecules of compounds. For example, a molecule of water consists of two atoms of hydrogen and one atom of oxygen to form a triatomic molecule H2O. Here are a few related numericals. Now convert 20 grams of water into moles. The molar mass of H2O, which consists of hydrogen and two atoms of oxygen, will be 2 into 1 plus 16 equal to 18 gram per mole. So 1 mole of water weighs 18 gram, which implies 18 gram of water is equal to 1 mole. Therefore, 20 gram of water will be 20 divided by 18, that is 1.11 mole. Calculate the number of molecules of sulfur present in 16 grams of solid sulfur. 1 mole of sulfur S8 is equal to 8 into 32, that is 256 gram, as 1 mole also as 1 mole equal to 6.022 in 10 raised to 23 particles will be present in that 1 mole. So therefore, 16 grams of sulfur will approximately consist of 3.76 in 10 raised to 22 molecules. Calculate the mass of 6.022 in 10 raised to 23 molecule of NH4Cl. The molecular mass of NH4Cl will be 14 plus 4 plus 35.5. That is molar mass of N 4 into molar mass of hydrogen plus Cl. Molar mass of Cl, that is 53.5 grams. Now number of moles of NH4Cl is equal to 6.22 in 10 raised to 23 particles, which constitutes of 1 mole. So mass of NH4Cl will be number of moles into molar mass. That is number of moles into molar mass will be 1 into 53.5, that is 53.5. Calculate the mass of 12.044 into 10 raised to 23 oxygen atoms. Now the number of moles of oxygen atoms. So here we are given this number of particles. So this divided by the Avogadro constant, that is 6.022 in 10 raised to 23, gives us 2 moles. That is 2 moles of oxygen atom. Now we have to find the mass of oxygen atoms. Number of moles into atomic mass, that is number of moles equal to 2 into 16, the weight of oxygen. 2 into 16 gives us 32. So here is the end of the session. Thank you.